Teardown time. This is a teardown of the Fitel S148 fiber optic fusion splicer. Let's see, how do we get this open? Looks like it's just 4 screws. There we go. There's some classic mid-90s type construction techniques. Lots of cables all over the place. Let's see what we have. Looks like that's one of the cameras. Let me just get a better angle here. Nice, primarily surface mount board. This must be the EEPROM for the program. Wondering if one of these might be the CPU. Let's take a look at that. COSOL DC to DC converter. What else do we have? That must be the camera. Connection going to the camera, one of them. There's the motor, looks like a stepper motor for the micro positioner. Some more boards, let's see if we can get light in there. Probably video output, that one's right near this video connector. There's the other stepper motor. Another second layer board there. Some big SIP module. And what else? And all the connectors. And there's this little metal box, shielded box that might be interesting. I wonder what that thing is. There's the other camera. This one is different from the other one. I guess they didn't have room on that side, so they had to put the control board off to the side. Fan for that little to cool the heat shrink down. I think this has a little heater. This is for shrinking heat shrink around the fiber optics. Then there's you can see a fan that cools it down after it's done. Okay, this top cover just comes off. Oh, that's pretty nice. That disassembles quite nicely. Now let's see what we got in here. Here's the date. Looks like this was made in late 1995. Let's see. We have backlight or inverter for the backlight for the LCD, LCD module. Really long aspect ratio fan, very steeply pitched blades. You probably can't see it there. Yes, backup battery. This must be the flyback transformer to generate the arc. That'll be interesting to play with. Yeah, there's the camera that they've looks like added a flex cable to. This one, the controller's just mounted straight on top of it because they had room. Some odd little capacitors and sort of surface mount caps in these little holders. That's odd. I wonder where the barometer is. I'm interested in seeing exactly what they're using there. Let's pull this thing apart further. Here's the underside of the mechanics block. Just a simple stepper motor driving gears, and I think this is there's a screw on this shaft, so when this gear turns it pushes this back and forth, and that pushes against the sleds, which are just held by a spring. It's pretty simple. If you look in here, you can see there's a let's see if we can get the view in. There's a little thing that looks sort of like what do you call it, the part in the microscope that has the lens on the end. This looks sort of like that. I'm guessing there's a lens on the end of this bit, and it focuses the light off a mirror on the end of this, off a mirror on this, bounces it onto the image sensor. And when it's doing a dust check, I'm guessing it might be looking for dust somehow in here, so let's open this up and see if it's dusty. And on this board, which is labeled the I/O board, it looks like we have the barometer right there. Wondering what type this is. I don't think they had MEMS stuff back then, although I could be mistaken. It could just be a large scale pressure sensor that compares relative to a vacuum. What else? We have, looks like over this side is probably a DC input board. A bunch of DC to DC converters on that. There's another one right there. This one says I/O board. Let's see. It's got this thing, which is probably the barometer, although it could also be the humidity meter. This there's this other device, TTR19203A. Doesn't look like it has any holes. I don't think it's anything to do with the atmospheric sensing. I wonder if this could be both a barometer and a humidity meter. So I don't see any other device in here that could be the humidity meter. Let's just take a look at this CPU board. I looked up a little bit on some of these ICs. This is a NEC V53A microprocessor, up to 20 megahertz. Well, this one's running at just under 19 megahertz clock, which means the instruction clock is half of that, so just under 10 megahertz. It has two 128 kilobyte SRAMs. Under here is that EEPROM we saw earlier that must store the program. This is an on-screen display or video generator chip that displays all the text and on-screen graphics. I believe it also uses this memory as part of the video buffer. This is a video output, I believe it's a RGB to NTSC converter. This one is a video ADC, I believe that's so the CPU can read video data when it moves the fibers together, and so it can measure actually where they are. The rest of all the rest of the stuff is just generally glue logic. And here's some close-ups of this board. And on this side as well, it looks like it's just a whole bunch of glue logic. And more close-ups of the other board. And of this device, pressure or humidity sensor. Or maybe this one device does both, because I don't see any other device that could be the missing sensor. This teardown wouldn't be complete without looking at the high voltage module. Nice snap together action on that one. Nice little flyback transformer in this. A couple of hybrid type circuit cards. Guess they needed more space. Wonder if that's this main transistor there. Yeah, nothing too strange in this one. I don't like how the main lead doesn't seem to be disconnectable. It's sort of stuck together with that unit. Probably some trim pots there for adjusting the amount of current or voltage it outputs. And while we're at it, we may as well look at the main power supply as well. There we go. Pretty nice, nicely built power supply there. Nice FR4 board. Looks like just a standard off-the-shelf power supply almost. They just built into this box. Standard terminal blocks. Yeah, there's a label there. This is put out 12 volts, 4.2 amps. I noticed one little bit bodgy thing in here. If you notice these leads on the capacitor, these are just PC pin, printed circuit board pin capacitors, and they've soldered wires onto them and run them down to the board, I guess so they can mount the capacitors horizontally to save space. Not quite what you'd expect for Japanese equipment. Looks like this is made by San-Kan, made in Japan. Ah, yes, this has, oh, interesting, it has two mirrors. It looks like it bounces it, probably, light probably comes in here, across, and then back up to make the distance to the image sensor longer. And let's look at the image sensors. Image sensor, yeah. There's the CCD right there. And there's the, must be the objective lens for the microscope. I can't really see it in there. This would be a fun thing to play around with just as a little microscope. Yeah, made by Sony, you can see the bottom there. Probably using Sony image sensors and Sony camera boards. I wonder if there's any dust on this. Yeah, there's a bit of dust. Looks like the mirrors could be cleaned. Looking at this mirror under magnification is actually very dirty. I'm guessing that's why it's failing the dust check. That looks cleaner than before, but it looks like the silver aluminum coating on these mirrors is just starting to wear off. I'm guessing they've been cleaned too many times in the life of this equipment. Well, it's still cleaner than before. It may help. I'll clean the other one so we can power it up and give it a try. That's all connected back up. Let's see if it works any better now. Now, how do we get past this? No. It certainly looks a lot cleaner. It looks, the images are brighter than they were before. And let's do a dust check again. Maybe that one. Some little dots are appearing. That's much better than before, it looks like. There was a little speck on the CCD I saw. I'm not sure how critical this is. Hopefully it's not that important. Unfortunately, it looks like I threw off the alignment of the cameras there. These two are supposed to be centered in each half of the screen. I'm just going to loosen up these mirror mounts and try to align the image again. While I was working on this, the other TV failed, so I had to swap it out for this other one. Yeah, I've loosened one of the things. This one doesn't seem to have enough throw, so I'm thinking. I'm thinking I may put it on backwards, so I'm going to try putting it on the other way. That's even worse now, so might have messed up some other alignment. That's as good as I can get it by moving that little metal piece. This should be centered somewhere in here, so probably going to have to try to calibrate it by moving around the CCD plate, as you probably should. Now that this little CCD mounting plate is free, we can try to align this. We just need to get the two fiber and the two images lined up properly. I've got this aligned the best I can now. I've got a couple of the best end fibers I can find in that little this little container. They're reasonably square, cut square. So let's see if this thing will work in automatic mode. Oh, wrong one. What? Must have rebooted it. How do we go on this? That's strange. Maybe it's unhappy that the the battery for the real-time clock is unplugged. Maybe it's unhappy with that. And here we go again. No, it's still unhappy for some reason. Yeah, it's rebooting every time I try to do that. I did a factory reset that I found in the menu. Let's see if this works now. Gap OK. Inspecting. Something error. Cut error. It obviously knows the cuts are not right. Let's ignore. Wow. Error code cleave obviously wasn't cleaved properly. Estimated loss minus 0.08 dB. That works surprisingly well. See if we can get back to the main screen. Yeah, you can't even see where the joint was. Yeah, I'm probably going to put this thing together and probably put it up on eBay. certainly not worth scrapping something like this. This is way too good. I guess the reason this thing was crashing when attempting to start the fiber splice was because of invalid data in the configuration memory. Probably because when you unplug this real-time clock, it forgets everything, and when you plug it back in, the RAM is all at random values, and executing that factory reset must have reset them all to the proper values. Looks like the arc counter is stored in volatile memory because that's been reset just when I plugged the battery back in. And also I noticed these two settings were, that was 0, that was 255 when I plugged it in. After doing the factory reset, it reset them to these values. Now that this is all back together, I think I'm going to have a go at selling this. I'll probably put it up on eBay and see if anyone wants it. Anyway, I hope you enjoyed this teardown video. Thanks for watching.